As a quick reminder about parallelograms, a rectangle is a parallelogram, a square and a rhombus are also parallelograms, and opposite sides are equal in a parallelogram. You can use the distance formula to work out the length of the sides, and opposite sides are also parallel, and in that case you can use the gradient, find the gradient of the lines and compare the gradients. If they're equal, then it means the lines are parallel. Another very important theorem concerns the diagonals of a parallelogram. So if you are given any parallelogram, A, B, C, D, then these two diagonals here will bisect each other. Bisect means they meet each other and cut each other into two equal halves. So suppose they meet there at point O. Right, so then it means the length AO and the length OC are equal because DB bisects AC. And also the length DO and the length OB are equal because AC bisects DB. So the diagonals of a parallelogram will bisect each other. And one way to prove it is to just work out the midpoint. So the midpoint of the line AC should be equal to the midpoint of the line BD. So if the midpoint of AC is equal to the midpoint of DB, it then means the diagonals bisect each other, which means that is a parallelogram. Right, you know about a square, there should be a right angle in a square and a right angle in a rectangle as well. Right, how would you find the points of intersection or the coordinates of the vertices of a parallelogram? So suppose you have a parallelogram. Let's call it PQRS. And suppose you know point P and you know point S and you know point R, and you are trying to work out point Q. Right, so what you can do is work out the equation of this line PQ and also work out the equation of this other line QR. Then you solve those two equations simultaneously. That will give you your point Q there. There's another method, a shorter method, the method of inspection. Let's use this example here. So suppose we have a parallelogram. Right, so this is a parallelogram. Let's call this one point A. I'll make it -3, 3. And let's call this one B, and I'll call this one -5, 0. And let's call this one C, and C is 0, 1. And then that is D, and we are trying to find the coordinates of that point D. Right, so if you want, you can work out the equation of AD as well as the equation of DC, and then solve those two equations simultaneously. That will take you quite a long time. It is easy to use inspection here, and this is how inspection works in this case. If you were to start moving from B towards A, right, so you are moving from B to A, how many units would you move horizontally? And how many units would you move vertically? So that should be 90 degrees. So you are counting the number of units you are moving horizontally and the number of units you are moving vertically. So at B, X is -5, but at A, X is -3. You will notice then that you are actually moving 2 units to the right. Then how many units up are you moving? At B, Y is 0, but at A, Y is 3. So you are moving a total of 3 units. Now, you can use that to determine the coordinates of D, because the same movement from B to A should be applied to C and D. So you ask yourself, how many units must we move horizontally? We said we should move 2. And how many units must we move vertically? And we said we must move 3. So for your point D, we are moving from C. X is 0 at C. Move 2 to the right. 0 plus 2 will give you 2. Then we move up by 3 units, but we are starting at 1. So 1, then go up by 3, you get 4. So your answer by inspection is just 2, 4. You can actually get that answer without writing down any working at all. Right, so just a quick reminder, guys, before you answer the questions. You can show that a quadrilateral is a parallelogram by proving that the diagonals bisect each other, and the midpoint formula will prove very useful there. You can also show that a quadrilateral is a parallelogram by showing that the opposite sides are equal, which means you can use the distance formula. I don't like that method, it's too long. You can also show that a quadrilateral is a parallelogram by proving that the opposite sides are parallel. Now for parallel sides, use the gradient. So if the gradients are equal, then the lines will be parallel.